Okay, a piecewise function, right? F of x is the piecewise function. It's called piecewise because there's different pieces to the function, right? There's one piece, which is x squared plus 1. There's another piece, which is x minus 1. Okay, when do you use each one? Well, that's what these are telling you here. These are referring to intervals on the x-axis, or the domain. It's telling you when x is less than 0, use this expression. When x is greater than or equal to 0, use this expression. Okay? So these are domain statements. So, for example, yeah. Okay, so basically, let me sketch this out real quick, right? This is a parabola. It opens up and has a y-intercept of 1, right? Right. This is a straight line. It has a y-intercept of -1. It has a slope of 1. Right? In a piecewise function, it says for x less than 0, we want to use this. So that means we don't use this. And for x greater than or equal to 0, we want to use this, the straight line, and we don't want to use that. So the piecewise function, you know, it looks like two different, like a discontinuous kind of thing. So now when I evaluate a piecewise function like f of -1, I have to choose the right expression, right? If x equals -1, which expression am I going to use? The first one, because x is less than 0. Okay, this is example 4. I'm not making these up right here. It's just part of the example. It says evaluate at -1, 0, and 1. So we would plug in -1 squared plus 1, which is 2. Right? Okay. Let's do the f of 1 next. Which function would we use? Which expression? F of 1. The second one, because 1 is greater than or equal to 0. So we would say 1 minus 1 equals 0. Okay, which one are we going to use for f of 0? The second one, because the or equal to is on the second one. Right, so we have to say 0 minus 1 equals -1. -1 squared is 1. 1 plus 1 is 2. Yes.